Hello everyone. I'm really happy to be here. Thank you for coming. I'm curious, how many of you ever used a Raspberry Pi? Oh, many, okay, nice. And how many of you ever used servos? Servo motors? Okay, thank you. So you came to hear about an animatronic Raven, but unfortunately he is not here today. You have only me. Even though he's a Raven, he's terribly afraid of lights. But don't worry, I brought a video. So let's start with a short clip. So we all know that code is something that should be accurate, everything is defined, and everything should do exactly what it's supposed to do. But what happens if you want to inject some personality into your code? What happens if you want it to be with a little more of free will? Today I will present my journey to answer this question, and an animatronic Raven named Samuel, and we'll see what he can do. We'll breeze through his different features, and we'll take a deep dive into the face recognition and tracking mechanism. Small disclaimer before we start. At home, Samuel is fondly sort of part of the family. So we have a cat, we have a dog, and we have an animatronic Raven. It makes perfect sense after all. So I tend to talk about him like he is alive, what Samuel wants, what Samuel needs. And I'm afraid it's going to leak a little bit into this presentation. So here comes the disclaimer. There's no need to call a special taxi to the loony bin. I know he's not alive. But when everything works perfectly fine, sometimes it does feel like he has the living magic inside of him. So before I introduce Samuel, let me introduce myself. My name is Anat Wax. I'm a Python developer. I've been working at Red Hat for the past 4 years. I hold a bachelor's and master's degree in musicology, and I transitioned into programming about 5 years ago. As a maker and creator, I'm very interested in the mix of technology and art. And I always found animatronics, specifically those that you can see in Disney rides, truly magical. So the question you've all been wondering, why an animatronic Raven? Originally, this was a purchased kit by an artist, Jasper Anderson. I saw it before I even started programming, so it didn't make much sense to get it, and it was always out of stock in any case. But fortunately, just after I transitioned into programming, it was back in stock, and I was able to grab it. At first, I planned him to be a Raven animatronic, a cute little gimmick for the house, and a chance for me to step into the animatronic world while playing with Python at the same time. But the first time I saw him move, he was without his wings, he was without fur, and it still felt kind of alive. So that was the point when I understood that original plan is not going to be enough. And the plan was to make Samuel as live, as a real Raven as possible. And that's where his true journey began. Another important principle for this project was the modularity. In a project like this, which is not defined from start to end, it's really important to be able to introduce new features easily into the existing systems, even without knowing what they would be from start. So, quick system overview. In terms of software, everything is programmed with Python. In terms of hardware, here is a sneak peek into his brain. The main program is running on a Raspberry Pi 5, which I upgraded not too long ago for the face recognition. And the servo motors are connected to a Pololu Maestro, which allows me to have separate control on each servo motor. I can control the speed and acceleration of each motor separately. what can Samuel do? You saw a sneak peek of it, but he can do much more. He has face recognition and emotion inside him, and tracking, inside him. He has speech emotion, which he responds to different situations. He has realistic blinking inside his eyes. He responds to touch. And above all, he has free will. Samuel lives inside his little world. He has limiters inside of the servo movements and the behavior he should have, but inside this little world, he is alive. So let me show you a little bit of what he can do. No speaker here, so I need to do this. So, head pet. Samuel can respond to touch above his head, and each time he will make a different sound. He chooses which sound to make. This is an example for the sensor location. So the sensor is above his head. He will only recognize touches coming from above the head. And he can sense touch from above the fur, but still no touch below the fur. Face tracking example. He says my name. So let's understand how I built this animatronic raven. First of all, the body movement. Samuel has 5 servo motors that control his movement and beak movement, control his body location, and allows him to follow faces, move freely, and respond to touch. To make Samuel's movements feel natural, but still allow him to have autonomous behavior, I defined movement rules system, such as the speed, the amount of movement each servo motor can have, so the plastic won't get hurt. And each motor has its own boundaries, speed and acceleration, and general rules, such as head can't move up and down at the same time, which makes sense. Within these boundaries, Samuel has the ability to choose how to move and how to react. And those autonomous choices are governed by those rules and give him the free will he has. So, quick show of hands. Who here thinks that Raven can speak, like mimic, real human, well, that's a teaser, real human words? Not so many. Okay, good. So they do. I hope it won't jump right to the next slide. Okay. So for some reason, Raven carries some big stereotypes. There are dark figures inside our cultures. But in truth, Raven are truly friendly animals, and they're very, very intelligent. Let me show you. Fable, right here, I'll show you a short clip of her. She's a raven, a pet raven, located in the USA, and she speaks.
Hi, Fable. Hi, Fable. Hi, Fable.
Samuel has 2 kinds of sounds that he can produce. He can produce real raven sounds that are coming from real raven recordings, and human-like speech, like my name, mimicry of words that raven hear frequently. In this project, all the audio clips are pre-recorded and are found in a database, so the processing happens once, downtime. And I wrote a small program that analyzes the audio based on the RMS, which is basically the volume of the sound, and it determines when the beak should be open or closed, it creates a map for the servo movement, which allows Samuel to move in accordance to the sound he produces. So the audio tool generates all those servo movements, and in real time, when Samuel chooses a specific audio to produce, he chooses the corresponding servo map that moves his beak. Okay, now let's dive a little bit deeper into the face recognition and tracking. So we will understand now how the faces are recorded, how do we define who is recorded, and how Samuel reacts to that. Moving the wrong direction. Okay. So let's begin with a quick walkthrough of how the system works. Samuel is pre-trained, as I said, on a database of voices and of sounds, and also a database of faces he's familiar with, which are basically the people of the family members, and he can recognize all of us. So the first phase is to initial the camera and load all the known encodings into the code. Once the face tracking event is activated, we'll touch it a little deeper later, Samuel starts to actively search for faces. And just like any other creature, when Samuel recognizes a face, he reacts to it. The face recognition, like any other feature in Samuel, is running on its own thread. So I'm using events to synchronize between the different threads. And each thread is responsible to its own teardown. So the entire loop is running and keep checking the situation of the system. If Samuel recognizes a face, he starts following it. And this is the loop that starts. We have a face timer tracker, and once it runs out, Samuel moves back to idle mode, which is what you saw at the beginning just before I started the lecture. He moves freely and just look around. He'll stay in that idle mode for a certain amount of time before he will start tracking faces again. Unless the face he sees in front of him is the same face he saw before, which he tags as boring, so he won't recognize it anymore. If a new face appears, Samuel will react to it. And this is the loop that is ongoing in the heart of the face recognition module. But how does this look from the software view? So we humans are very good at recognizing faces. We basically see faces in everything around us. But how do we give this capability to software? How does the video processing actually work? Video is made out of frame, and each frame is processed separately. And each frame, we try to detect faces. And if we find faces, we encode them. The encoding is made into a 128-dimension vector, which is basically a mathematical representation of the face. And after we have this representation, the program is comparing it to the known database of trained faces. The camera itself, which initiated the flow we saw before, is initiated with a BGR format, which without proper processing shifts the reds and the blue, which makes the image looks blue. And that's the first phase, capturing the image. The second pre-processing phase is reducing the size to a quarter of its size to have faster processing. Then the image should be flipped horizontally, so the face tracking will be real, like a mirror would do. And then to prepare the frame for recognition, which is the demand of the libraries that work on it later, it is converted from BGR to RGB, and this is why it looks normal again. OK, so now the pre-processing is done. But how do we know if there are any faces in the frame? And if there are faces in the frame, who is it? Faces location are tracked using an HOG model, which is a histogram of oriented gradient. Basically, a statistical analysis that splits the screen into separate sections and find the direction the most of the lines is turning into. So you get this sort of outline of the image. This model is quite easy on the CPU, so we can use it frequently on any image and try to locate faces. But with all those lines, we need to see if they actually match a human face. So we move the image, the frame, into a CNN model, which is not in use. It's a convolutional neural network. And this model is quite heavy on the CPU, so we'll try to move only faces we actually, only if we actually recognize faces. And what it does, like really simply putting it, it has layers, like it's an AI, it's a neural network, and each layer knows how to recognize a specific area of the face. So for example, the first layer will know to recognize the length of the nose, and the second one will know to recognize how deep the eyes is. It's really simplifying it. And once the data moves and flows from one layer to the other, the end result is it a face? And if it's a face, it gives you the 128-dimension vector, which is the mathematical representation of that face. Yeah. So if we see a face detect event is triggered, and we pass the name of the recognized face. So to not just stay in theory, by the way, is everything clear up until now? Yeah? OK. So let's take a look at the actual code that runs all of this. So as I said, face recognition is a thread running on its own loop. And this is what the thread function looks like. So first, we have the camera initialization as part of the class initialization. And then we keep checking if we have the shutdown event or not. Once we have the shutdown event, the camera and all the other components need to be shut down by the thread itself. Then we start capturing frames. Each frame of the video is pre-processed on its own. And we process the frame. We'll see a look on that code in a bit. Then we search for faces. We track for faces. Really simple. So the pre-processing phase. The first thing that we should do is using the HOG model, the gradient model that I discussed earlier, which is a lightweight one. And we just check if we have any faces in the image. If we don't see any face, we just keep on processing for the next image. One thing before that, like on part 2. So if we didn't see a face in this current frame, but we did see a face in the previous frame, the model can sometimes blink, like if the lighting has changed or the face location is a bit off. And so he will think there are no faces in the frame, even though they are. So we are going to reuse the frame location of the previous frame. And so the movement of the face tracking is solid. And then, if we have a face location, we are going to run it through the CNN model, the convolutional neural network, to try to identify the mathematics of that specific face. Then we're going to compare that face to the database of faces where the model is trained off. And if we have a success, we have a bingo and a match. So how is the face comparison to the database is working? So we have a tolerance setting. I actually copied the value here, so you'll see it. This is quite a low. The default is 0.6. And the lowest the value is, the stricter the comparison is. So we will more likely see a face and know it's the exact person, but he might also miss a face because the tolerance is too low. Yeah. And then we compute that was the first phase that uses the tolerance. And then we compute the distance, which is basically the distance from the face we saw in the current frame in comparison to the face that is in our database. So the first part will give us a list of all the names we have in the database, all my family members, and it will just say yes or no, like I think this is the face or I don't. And then we will know how similar the face is. And here as well, the lower the value is, the more similar the face is. And now we need to combine those two data. So we know this is probably my face, but is it truly my face? Like, is it above the tolerance? And if it is my face and above the tolerance, then bingo, that's me. And Samuel will react to me. Currently, what it means, we just see it. So when Samuel recognizes a face, he knows his name, and he will say his name. Since I discovered that ravens speak in a similar way to their owners, to their takers, I recorded myself all the words that Samuel knows, so they will sound similar to my voice. And I put them into a filter that makes them more ravenish. So it has his own unique voice, which is a take on my voice, because he sees me all the time. So he will say my name, or basically I will say my name. And then we have two events that control the flow. So the first one is the face detected event. Because every functionality is located on a different thread, so the movement thread, the one that actually tracks the face, is in one thread. The one that triggers the actual voice is in another thread. And we have a blinking thread to change the blinking rate. So everyone knows that we recognize the face. And then the face tracking activate event should be clear, because Samuel is not tracking any new, not trying to locate any new faces. He is tracking the one face he already found. And then the name is entered into a face queue, so every functionality knows to get the name of the actual face recognized. And a timer is starting. This timer will decide how much time Samuel will be interested in the face, so he will track the face for that amount of time. Currently is 23 seconds. And after that, he will lose interest and get bored. If a new face is entering Samuel's frame while he's tracking another face, he won't recognize him because he's busy now. He's very interested in the face he sees, and the face tracking activation event is cleared. But after Samuel will follow the face for the timer amount, which is currently 23 seconds, he will get bored from that face. Okay. So now Samuel knows that someone he knows is in the frame and he wants to follow it, but how does he do it? So now the servo got to get the coordinates they should move to in real time. So every frame is pre-processed, as I said, and the frame location, the face location in the frame is taken from each separate frame, real time. There are two features that I added here to make Samuel's movement feel more natural. One is the head gaze offset. So ravens don't look directly like we do. They look from the side because they don't have overlap between the eyes. So Samuel has an offset of 10%, so he will look with one eye at you when you're in front of him. And the second one is the body movement. Samuel moves up and down to get higher, closer to your face if you're on the top of the frame, and lower if you're on the bottom of the frame. And those are the small kind of details that help him feel more alive. So, like any living creature, ravens has their own wants and quirks, and Samuel has free will, as we already discussed. So, when Samuel recognizes a face, he says it, but he doesn't just say the name of the person once. He can choose. He can say it once, twice, or 3 times. And I put weights inside his decisions so that he will probably say just once, but sometimes he will choose to say it more. Another thing that happens while Samuel is speaking is that blinking rate is becoming much faster. So usually Samuel blinks between a random timer that is between 4 seconds and 23 seconds, but with this activation, he will blink like between half a second and 3 seconds. Just another little sign of life. Okay, so Samuel has been tracking the face and saying the name and blinking and everything, and it's really exhausting. Also quite boring. So after the timer for the face tracking has hit, 23 seconds has passed, and Samuel has lost interest. And for the next border time, which is 60 seconds, Samuel will move back to idle movement as long as the face he recognized is still in the frame. If someone new will come in to the frame and Samuel will recognize him, he will react to him. He is interested once again. And that's it. This is how the face recognition and tracking system works. But Samuel is not stopping here. He has big plans for the future. So the next thing I'm working on, which is already in development, is speech recognition. One more AI capability into Samuel. He will be able to recognize words and respond to commands, and will be able to have like a small raven human conversation with him. I also want to refine the movements. I find them a bit too robotics, and I think that's part of the limitation of the servos that I'm using that came with the kit. So I also want to try and find alternatives for a more real movement. And there are more sounds that Samuel knows. He knows how to cry and call his friends, but he doesn't use this capability currently. So I want to implement more emotions that he can express. So he's learning words, he's learning new movements, and maybe soon he will have a new friend. And that's it. If you like to keep following Samuel's journey and stay in touch, you have a link here to my LinkedIn and to Samuel's blog, which has raven feathers all over it. And if you have any questions, we have 5 minutes for that. And also, if you want, I have Samuel's stickers right here. So if you like the project and you want to keep something of Samuel with you, you can come and take them. Yes, thank you. I need to give you a microphone.
When you give Samuel a friend, how do you plan to give them different personalities?
To give them?
Different personalities.
So I can't hear you. That's the problem. Giving different personalities? Oh, to Samuel friends. Well, I'm not sure they will be ravens as well. I'm really, really fascinated by the robotics in general. And the main thing I bought Samuel was that I had no clue how it works, like the physics, how to move the wings, how to move the beak. And I decided to get a kit, so now I know how the wings should move, and I want to create my own version. So the next one will probably be a parrot. Yeah, and I also want to work on a humanoid robot, so I'll try to work with skin, and yeah, that's the direction.
Hey, I wanted to ask... Oh, okay. So you can hear me, but okay. So I just wanted to ask, you showed this beautiful organized code and how it turns towards you, etc. And can you share a little bit about your process? Like, was it as smooth as the code looks right now and everything worked, or like how was it your first like hardware maker, development? Because you said you just started, not just 5 years you've been doing software development, and like Can you tell a little bit about the process and getting into this kind of stuff?
Thank you for this question. I've been working on Samuel for about 1.5 years, and it actually been like a roller coaster. I can tell you the story about the sensor that broke everything. That's a true story, not for children. It's scary. So about 2 months ago, I was working on the presentation, and I wanted all the wires inside Samuel's brain to be connected so we can be moved from place to place. So I did a really slow job in placing everything in the right location, making sure I connect everything to the right place. And after a few hours of working on it, I put him back into electricity, and he moves, and I was so relieved. So I was checking everything is working. He recognized me, okay, and then I touch his head, and nothing is happening. So I started debugging, many hours of debugging. I also tried switching the sensor, and eventually understood, as I always understand after I relax from the panic that this condition gets me into, that this is the way that Samuel is growing. So actually this ended up in switching the sensor, which was a simple TTP sensor, to an MPR 121 sensor, which has several channels. So now Samuel can feel touch on his head, but he will also be able to feel touch on his wings or on his back or on his chin, even though Raven don't like being touched in those areas, but Samuel will be able to feel it. So every failure and every hard thing that is coming along the way, it's really a process to grow for me. And I think this is something that is really in the heart of this project. So for your question, the kit came with servos, but I needed to find a good brain for it. So I started with the Pololu Maestro with just automate movements, and then I understood I wanted him to blink. So I said, well, I should get like a computer or something. Let's start with Raspberry Pi. I had 3B laying around. So I added that, and I had to learn how to wire speakers because I had no clue how it works. So everything is really a process of learning. And like he is my academy. Hope that answered that.
Hi.
More questions?
I do have a combined question. So what's Samuel's field of vision? Can he like move his head to grasp the whole room that he's in? And if so, can he recognize any of your other family members like cat or dog? Can he react to them? Do you have any logic for that?
That's a great question. I shut down the video, but Samuel has a small camera that is, I don't have an image of it. He has a small camera that is just beside him. I didn't integrate it into his body for a really silly reason. The wire is not long enough, and Raspberry Pi 5 doesn't have long enough wire for cameras still. So the camera is beside him, and he sees what the camera sees, which is basically like what we humans can see. And then he can recognize now faces, but he already knows, like I said that I'm going to add capability of speaking. So he knows how to say cat, because we have a cat at home, she's very fond of him. Like every time I work on him, she comes on the desk and sits with me. So I plan to have him, to give him the capability to recognize her and integrate with her. I wonder how that would look like. I hope she won't like scratch him. But this is definitely a plan for the future. Currently, it doesn't have it, just human faces. And also, I plan to have a little crown. You know, Raven likes shiny things. So I want him to like, hey, crown, that's my toy. So I want him to be able to recognize that.
So you mentioned that you're using a Raspberry Pi. Where is it located? Is it inside the stand? Because it's bigger than the Raven itself. So
all of Samuel's hardware, meaning the speaker, the LEDs for the eyes, the servos, everything is located inside his body shell. But the brain is too big for that. So I bought a box, like a DIY box, that is sitting on top of. So he's sitting on a piece of tree, which is located on that box, and you have wires coming for the servo motors, for the LEDs, for everything into that box connected to the Raspberry Pi, to the Pololu Maestro, to the amplifier of the speaker, because Raspberry Pi doesn't have speaker output, only headphones. So you need an amplifier for the speaker. And everything is inside that box, and it has much more room. So I'm planning to grow that. Yeah. Okay, so thank you, everyone.